Hey guys, my name is Juliana Ocampo Marin. The rest of our teammates are Wen, David Rubio, Jonathan Johnston, and Anaz Shahid. We will be designing a temperature-controlled 3D printer enclosure, which is essentially a cross-flow heat exchanger.
Hello guys, so in this slide, I'm basically explaining what the project is about. So the team is going to be doing some research on the heat exchanger, which basically encloses the 3D printer and regulates the temperature using thermostat and a couple of exhaust fans that turn on and off automatically. So the team is going to do this by designing the software and creating parts on the CAD using the CAD software, and then using thermostat controllers to collect data and give feedback to the computer. That possibly turns the exhaust on and off and regulates the temperature. The team is then going to be creating a prototype of this enclosure and finally creating a video report to communicate the whole process behind designing the enclosure and what goes into the details in constructing this enclosed 3D printer system. Thank you. Next slide, please.
Thank you, Anaz. And so there's two types of enclosures. There's the heated enclosure, which is a closed one, and an open enclosure, which is not heated. And so a heated enclosure is able to maintain a constant temperature, which increases reliability and printability of a printer. It also has an enclosed area, which reduces exterior input, such as cold drafts and dust. So open enclosures, since they're open, they have an open frame. It's more for just bump resistance in case you're walking close to your printer. And filament can also be mounted on top of this exterior enclosure, and it removes the excess weight from the printer, reducing vibrations. And so I'm going to pass it on to Jonathan.
Thank you, David. Our motivation for this project is that there's not a whole lot of enclosures out there that you can build yourself that are relatively inexpensive. You can get a printer with an enclosure, but usually they're a couple $1,000s more with that printer. So we're trying to make something that's less expensive than that. And we just want to make this enclosure the most reliable and efficient that we can, and that everybody, from people who have different printers, it would all be compatible for a professional printer or for more of a hobbyist printer. And we believe that MATLAB Simulink can provide a reliable program as well as our physical hardware and make a good system. Now I'm going to pass it on to Nguyen.
Thank you, Jonathan. So the objective of our project will be to design a control system for thermal regulation of an enclosure for 3D printing. And the control system will include a feedback loop to release hot air based on temperature. Our team will install a thermostat system that feeds the HVAC system to regulate the environment for the 3D printer to work at consistent temperatures.
So here are a few references that we used to create this report today. Appendix 1 will have your video presentation link. Appendix 2 will have your Gantt chart with our individual tasks and progress. And thank you so much for your time.
Thank you.
Thank you, guys.
Thanks.